Okay, I'm back, ready to do some linear equations writing practice. So this one is page 12 in your packet. Let's take a look and see some other applications for y equals mx plus b and some linear equations. So a consulting firm charges a base price of $100 plus a charge of $43 per hour. Can you guys take that situation and write a linear equation in, we're going to do slope-intercept form. You've got to recognize the vocab. Slope-intercept form is y equals mx plus b, slope y-intercept. That gives the total cost of the consultation, the cost y, as a function of the time of the consultation. That just means y depends on x. So x is going to be our independent variable, and y is our dependent variable. Y depends on x. So it's still just going to be a regular old y equals mx plus b. Can we do this? What do we know? We don't know y. We know y equals, we need an mx plus a b. What are the numbers here that we've got? We've got a per hour. This is how many hours? What's the charge per hour? $43 per hour. And a starting point for us is that there's a base price of $100. No matter what, we start out at $100 for this. There you go. There's our y equals mx plus b. I think you guys could have done this before. Can you find the cost of a 12-hour consultation? If they work with you for 12 hours, what do we do with the 12? We plug it in for x because that's our hours. So y equals 43 times 12 plus 100. If you need to go grab a calculator, you can do that or open one up on your Chromebook. I've got mine right here. So 43 times 12 is giving me 516. Then I've still got to add my $100 in at the end. I'm doing my multiplying first. So 616 what? Dollars, because this is the cost. So I just want to expose you to as many different situations as possible for linear equations. I'm going to have you guys look at problem number 2. My cell phone plan includes a $29 charge for all of my calls, plus a charge of 40 cents per text that I send. Can you go ahead, pause the video, do parts A and B, and turn it back on just to check it real quick. All right, so we want a slope-intercept form, y equals mx plus b. What do we know? A $29 charge for all the calls total. So $29 doesn't depend on anything else, but it's $40 per text. So I'm supposed to write a function of the number of texts that I send. So that's my x. So did I say $40? 40 cents? $40 per text would be a lot. 40 cents per text, so 0.40 per text. There's our equation. If I send 15 texts, that's my number of texts. Can I plug it in? Plug it in. 0.40 times 15 plus 29. Let's see what that's going to be. Clear this out. 0.4 times 15. It's going to be 6. And then 6 plus 29 gives us $35. Make sure you've got that dollar sign right there. All right, there's our y equals mx plus b equations. Let's look at the next page. This page 12 now, this is something new. We have not done this yet this year, and I think you are going to be fine with it, but it is a little bit new. We're not going to be writing equations in y equals mx plus b for this. I want to show you when it is easier and more beneficial to write equations in standard form. Does anybody remember what standard form is? Yeah, that's when the x and the y are on the same side of the equal sign. And usually we write it like this. ax plus by equals c. And those a, b, and c, they all just stand for some sort of numbers that are in the situation. So we're going to be writing these in standard form because when it's in standard form, we can find both the intercepts, the x and the y intercepts, really easily, and that'll help us answer some questions about these particular problems. So number 1, let's look. It is the yummy, yummy question. James spends $24 on cookies and ice cream at the store. Yummy. Cookies cost $3 a box and ice cream costs $4 a carton. We're supposed to try and write an equation in standard form to represent the situation, and it gives us some variables. Let's let x equal the number of cookie boxes, and y equal the number of ice cream cartons. So how are we going to put that information together? We know we've got something x plus something y equals something here. And if x stands for the number of cookie boxes, how are we going to figure out what to do at this point? We're trying to figure out a total cost. Do we know how many boxes we buy? No, but we know the cost. $3 per box. So $3 per box of cookies. How much does each ice cream carton cost? $4. So this over here is going to be the total cost of all the cookies, and this is the cost of all the ice cream. So added together, it should give us our total cost. What is our total cost that he spends? 24. We've got 3x plus 4y equals 24. That is in standard form. So do you remember how to graph that equation? By finding the intercepts, the x and y intercepts. Remember when the x-intercept is when y equals 0 because it's where it hits the x-axis. There's no up and down. And the y-intercept is when x equals 0. So for us to solve this, we're going to just do two sets of problems, and we're going to plug in what if y equals 0, what if x equals 0, and see what we get. So if y equals 0, 4 times y is basically gone. You have 3x equals 24 because that 4 times 0 went away. To get the x by itself, divide both sides by 3, and you get x equals 8. So we know when y equals 0, x equals 8, 8 comma 0. There's our x-intercept. All right, let's do our y-intercept. I'm going to use a different color. I'm going to plug in x equals 0, so 3 times 0 goes away. And all we have left is 4y equals 24. Divide both by 4, and you get y equals 6. So when x is 0, y is 6. X comma y, 0 comma 6. Can we take that now and graph the equation? I only put the first quadrant on here because these are all positive numbers. So let's take a look at graphing 8 comma 0 and 0 comma 6. 8 comma 0 is side to side 8. Let's see, 1, 2, can't see this very well. 1, 2, 3, 4, 5, 6, 7, 8. Looks like right here. There's my 8 comma 0. And let's try 0 comma 6. 1, 2, 3, 4, 5, 6. There's my 0 comma 6. Can I connect those dots and make a line? I'm going to do my best here to do that. So that's my linear equation that I wrote in standard form right here. The question is, what do those intercepts really represent on this graph? Why did we do this? Why do we care about those right here? This is the real question. So if you take a look at that, the x stands for number of cookie boxes. So here, this x would be the number of cookie boxes at 0, and the y stands for the number of ice cream cartons. This would be the number of ice cream cartons. If we bought 0 cookie boxes, how many ice cream cartons could we get? Exactly 6. And at the other end of it is, if we bought 0 ice creams, the y, we would buy 8 cookie boxes. So these intercepts are kind of the endpoints of what would happen if we bought 0 of one and all of the other. 0 of one and all of the other. And everything in between on here gives us all different possible combinations. So right here, let's see, that looks like that might be a point. I don't think it's exactly on there. I think that's a little bit off, but somewhere around 3 comma 4 is going to be close to giving us this. It means we could buy somewhere around 3. What was the x down here? The x was cookie boxes. And the y was ice cream cartons. Somewhere around 3 ice cream cartons or 3 cookie boxes and 4 ice cream cartons. And we would be able to spend that $24. Now, looking at this, I'm not sure that it hits exactly at any perfect point to give us whole numbers. It might be that we don't have very many good combinations that would make up this $24. But all of these, like here, let's pretend we're here. If we could possibly buy 4 and a half cookie boxes and 2.5 ice cream cartons, we'd probably be set. The idea is that these are all the different possible combinations, and some might not make sense if you can't have a whole box or a whole ice cream carton, but that's what it's representing. So if we wanted to put what the x-intercepts represent on the graph, we're going to say that 8, 0 is the maximum cookie boxes you can buy. It gives us the maximum cookie boxes if we bought no ice cream. And 0, 6 tells us the maximum ice cream we could buy. So they give us the furthest most points we can reach. All right, I'm going to have you try that again now, looking at number 2. You're going to read the question, you're going to pause the video, and you're going to give this one a try, and then turn it back on to check. Be really careful because you can see down here that you're going to need to count by 2s on this graph when you actually do graph that. So go ahead and do part A, part B, part C. If you want to do part A and then unpause and just check to make sure you've got it, and then pause again before part B, then that's fine too. Okay, so this one's talking about pizza and subs at a basketball game, raising money. So if we are going to put this together, it says each sub sells for $4 and each pizza sells for $6. And we're using X for the subs and Y for the pizzas. So $4 per sub, 4X, plus I've got to add my pizzas, $6 per pizza is going to be 6Y. And how much do we make from selling all that? This is going to be the amount I make from subs and the amount I make from pizzas, and I raise $60. There's our standard form, so our total amount right there. Let's find our intercept so that we can graph this equation. The x-intercept is y equals 0, y-intercept is x equals 0. If I plug in y equals 0, that term goes away. I end up with this. So I'm going to divide both sides by 6, and I get that x equals 15, and my x was my subs. So this is 15, 0. If I plug in x equals 0, this term goes away. I have 6y equals 60. This one's a quick one. Divide 60 by 6, and you get 10. And this was ice creams. No, not ice creams, pizzas. Goodness. So when x equals 0, y equals 10. And if we graph those guys, all right, I just had to count by 2 so we could fit it on here. So let's see. X-intercept 15. So this is 2, 4, 6, 8, 10, 12, 14, 15 would be halfway between there. That's our 15, 0. And then 0, 10, 2, 4, 6, 8, 10. Right here. I feel like I need to label pizza and X was the subs, just so that I can remember which one is which. And if I connect those dots somewhere in there, what do the intercepts represent on this graph? Well, what are the possible number of subs that we could get? What's the maximum number of subs you could buy if you bought 0 pizzas? You could get 15 subs. So we're going to say the max number of subs is 15. And the maximum number of pizzas you could buy if you didn't buy any subs is 10. So they give us our highest possible number that we could do. All right, so that's one of the main reasons that we use intercepts is they give us kind of maximums in situations. What's the highest you could go? Intercepts also give us a way to find different combinations, right? If you bought 0 of these, you could buy 10 of these. If you bought 15 of these, you could buy 0 of these. So they're a very quick way to get different combinations that make this equation true, to get an x and a y that work. All right, let's do one more page. I think we've got 2 more problems left in this packet. So flip over to 14. 2 more problems. And we're still working with standard form, but this time we're not graphing. For a school fundraiser, students are selling chocolates for $1 each and foam fingers for $5 each. We should have put our future entrepreneurs on here, and I have our pop and our fidget spinners and everything going on. That would apply to this situation too. But let's say that one student sold both of those things and ended up selling $80 worth of products. So what would be the equation we could write in standard form for this? Now this time, I'm not giving you an x and a y. We totally could. We could use an x and a y for this, and we could try and say that the chocolates are x and maybe those foam fingers are y. But I want to show you what it could look like without the x and the y also, with just other variables. So let's say for this time, I want to use C for chocolates, and we'll use F for our foam fingers. It kind of makes it easier to remember which is which when you're using letters that stand for those variables, stand for those quantities. So if we've got the chocolates for $1 each, then when they sell them, they're going to sell $1 times how many chocolates? And when they sell the foam fingers, it's going to be $5 per foam finger. And how much did he sell total? $80. So do you see that we could easily use X and Y instead of C and F? I'm just going to choose C and F here, again, because I don't have to graph it in this case. But I am going to use the idea of finding the intercepts. If this was an X and a Y, could I find those two maximum values? What's the maximum chocolate I could buy and the maximum foam finger I could buy? And I'm pretty sure you could figure this out without doing the linear equation for it, but show me. Show me what you can do with it. So two possible combinations, if I use this idea of X and Y intercepts, what if C equals 0 and what if F equals 0? Those are the easiest ones to plug in to find combinations that work for this. So if I plug in 0 for C, that whole thing goes away, and all I have left is having all foam fingers. So if I divide by 5, I get 18 divided by 5 is 16. I get that if I had 0 chocolates, I could have 16 foam fingers. I'm going to list that as one of my combinations. 0 chocolates, 16 foam fingers. That is an intercept, and it gives me the maximum number of fingers that I could buy. On the other side of it, if I bought 0 foam fingers, I'm going to plug in 0 for this, and that goes away, and I have 1C equals 80. Well, we know that the chocolates are $1, so you could buy 80 of them. C equals 80. So if I had 80 chocolates and 0 fingers, that's another combination. So I'm giving you a way, if you can write it in the standard form, you can get combinations really quickly by just plugging in 0. Are there other combinations you could do for this? Did you have to do zeros right there? No. What if you wanted to buy 1 foam finger? Could you have plugged in F equals 1 and then solved it to see what C would have to equal? Sure. And we know that if you're buying 1 foam finger, that's going to take the 75, right? That's going to be $5 out of there. So you can do this without having to show the X and Y intercepts. It's just really a fast way to do it. So can you try number 4 and try doing it with the intercepts? And you can get more combinations if you want to, because there's a lot of combinations in between. But pause the video, read this, try and write standard form. It's up to you if you want to use X and Y's or if you want to use different letters for your variables. And try and give me a couple combinations of apples and grapefruits. Go ahead and pause it. All right, here we go. We're going to write an equation in standard form for this. Apples are 50 cents each. 0.5, I'm going to use A for apples, just for fun. And grapefruits are $2. So $2 per grapefruit. I'll use G. And if I add those up and put my apples and grapefruits together, I want to spend $16. So that goes in here. There's my equation. So two possible combinations. The easiest combinations are what if I buy 0 apples and what if I buy 0 grapefruits? What would the others be? 0 apples, plug in 0 here, and that whole thing goes away. So it would be all grapefruits. 2G equals 16. Divide both sides by 2, and I get 8 grapefruits. If I bought 0 apples, I'd obviously be able to buy 8 grapefruits because I'm spending $16 and they're $2 each. 0 apples, 8 grapefruits. If I bought 0 grapefruits, I'm going to plug this in, and 2 times 0 goes away. So all I have left is the first part. 0.5a equals 16. Be careful with this. When we divide by 0.5, when we divide by a half, our number should get bigger. We should be able to buy 32. It's going to double our number. 32 apples because they're 50 cents each, and we have $16. So 32 apples and 0 grapefruits. So this is just an example of how intercepts can be used to find maximum points in situations and give you some different combinations. And you guys are now done with your linear equation work for the year. Woohoo! Nice job. All right, so you are going to use the rest of this time to do, this is your last work day for some PLP. I am going to expect you to be able to have your screen showing to Mrs. Driscoll so that she can see what you are doing and make sure that you are actually using this time for math. So I'm going to have you, wherever you are sitting, turn so that your screen is facing the front up here so that we can see what everybody is doing. And I will see you guys again next week, or come say hi to me tomorrow. All right, bye-bye.